Yes, recording have been started. तो कैमरा को इधर भी घुमा दो तो सवाल है जी इसमें। ये कुछ हो रहा है डिनर कौन कौन करेगा? जो पंडित को कल से बोल दिया करेंगे।
So we have very less time, so we have to conclude because 12:30 is a lot. So please, you all sit here. We can start. Robin, we can start.
Yes, yes, sir.
So here I have included a technique which is already published in the biological signal processing and control, and it has the impact of the Heisel 5. So this technique is already published in that research paper. So I have included the details of that paper, and the technique is based on the tunable Q-wave transform. So regarding the parameters of the discrete wave transform, there are the different tuning parameters, and by that tuning I just extracted the features and used the support vector machine to classify different class of arrhythmia. Okay, so the types of the regarding the arrhythmia, there are the 8 classes: normal, L triple B, R triple B, APVP, PVC, FPNB, and FBNB. So all these are the types of the arrhythmia. Regarding the L triple B, it is the left branch bundled block. So it is the types of irregular rhythm related to her. Left branch bundled block, right branch bundled block, atrial premature beat, paced beat, premature ventricular contraction, fusion of paced and normal beat, and fusion of ventricular and normal beat. So normal is denoted here by N, and the 7 arrhythmia, L triple arrhythmias, L triple V, R triple V, APV, P, PVC, FPNB, and FDNB. So these are the kinds of the arrhythmias. Okay. So we in this technique we have just classified that types of arrhythmia. Now here, if you just see the morphology and the waveform of all these kinds, so the A is the normal, and the rest 7 are the abnormal, and it has the name mentioned here: B, C, D, E, F, G. That's whatever the name. L triple B, R triple B, APB, PVC, paste, FPNB, and FBNB. So these are the types of the arrhythmias. Okay. Now Regarding the block diagram, what is the block diagram I have just followed here in this technique? First, I have just acquired the raw AC signal. After that, perform the pre-processing to remove different kinds of noises. After that, RP detection and bit segmentation. After that, wavelet-based cumulative wavelet-based features extraction. After that, training and testing. Okay. So here, for the raw EC signal acquisition, I have just taken the data from the MIT-BI's data arrangement database, which consists of 48 ambulatory ECG records taken from 47 subjects. So 47 subjects data is in the form of 48 records. Number of bits are 2, sampling frequency is 360, resolution is 11 bits per sample, means for each sample represented by number of bits is 11. So this is the resolution, and baseline is 1025 to display the ECG, and gain is 20 dB. Okay. So this is the description of the arrangement database. And regarding the pre-processing, I already told you how you can just pre-process the signal, and basically the pre-processing is involved with the removal of the noise, different kinds of noise as due to the different artifacts. So artifacts removal is just covered here in the pre-processing part, and for the pre-processing, I have just used the SC filter, essentially Bode filter, and after that, high-pass Butterworth filter is also used to remove the different kinds of high frequency and low frequency noise. Now, for the RPIC detection, so RPIC detection is in itself it is a field of the research how you can just detect the RPIC. But if you just I just tell you regarding the benchmark in the RPIC detection, the Penn-Tompkins algorithm is the benchmark in the RPIC detection. So here in this case, for the RPIC detection in the AC signal, the Penn-Tompkins algorithm is used, which offers 99.3% QRS detection accuracy. So in this case, we just use the RPIC detection because we have to just perform the bit segmentation. So bit segmentation can be performed by just firstly we have to just detect the RPIC. So that's why Penn-Tompkins algorithm in this case I have just used. So So in the regarding the different steps of the RPIC detection, we can just count all these steps as bandpass filtering, derivative operation, squaring, moving window integration, and adaptive thresholding. So all these are the steps of the Penn-Tompkins algorithm, and all these are implemented in the blockwise in the RPIC detection using the Penn-Tompkins algorithm. So the effect you can just see. I have also included the slide of the waveform how all these steps affect the signal. So firstly, in the bandpass filtering, why we just use the bandpass filtering? Because it just improves the SNR, signal to noise ratio, and it also removes the any if in pre-processing if any parts remain. So all this remaining part of the noise can also be cancelled in the bandpass filtering. And for the passband of the bandpass filtering, the chosen band is 5 to 15 Hz for the MIT-BI, and it just maximizes the QRS complex energy. Okay, so that's why this band is used here. Derivative operation has the motive because it just gives you the information of the slope of the signal. So that's why after the bandpass filtering, we just perform here the derivative operation. So it give you the slope information, and after getting the slope information, the squaring operation amplifies the signal. जो भी स्लोप आएगा उसको और जो लेस स्लोप का है उसको और मिनिमाइज करेगा, जो ज्यादा स्लोप है उसको मैक्सिमाइज कर देगा. So it maximizes the squaring operation, amplifies the output, and makes all data points positive. इसका ये significance है. After that, we have just used the Penn-Tompkins algorithm. After that step, moving window integration. So it just integrates the data and represent that. And regarding the significance of the moving window integration, it just we just perform here the 36 MWI operation, which just acquired the QRS waveform, and also it gives you the means in combination of the, because integration means combination. So it just 36 point combine that and integrate that, and it just highlight the slope information. So it is the significance of the MWI that. And after performing the MWI, we have to just put the threshold to just highlight the peaks. So adaptive thresholding, because the signal is not one single, it will vary. That's why adaptive thresholding is used. And if you just study the paper, the thresholding details is also there. How much thresholding by some multiplication factor 1.5, 2.14, all these kinds of factors have been used in adaptive thresholding to just detect the different peaks plus peaks. So here for the record number 121, here you can just see after the pre-processing the signal looks like that. After the band pass filtering in the band 5 to 15 hertz, it will look like that. After the 5-point derivative, it will looks like that. So here you can just see the slope camp. After the squaring operation, it just makes all the signal positive and just highlight. All the parts will remain zero here. This is a zero here mentioned. And the slope, the part associated with the slope are only there. After the, so here you can just see after the squaring operation and the moving, after the moving window 36 point moving into moving window integration, the this part becomes after the squaring operation and after the MWI, the part is very clear, which is means peak. So by this point, please don't talk. You can go outside. Okay. So sorry, whatever I just told you, because you are participant, you are guest here.
Yes.
But we have to also mention some decorum in class. Okay, that's why. Okay.
Sorry, sir.
नहीं, मुझे मैंने आपको बोला बाहर जाने के लिए, मैं नहीं बोलना चाह रहा था क्योंकि आप बाहर से हैं, आप गेस्ट हैं हमारे लिए. तो यहाँ पे यू कैन जस्ट 36 point. So after the R peak detection, here you can just see the detected peaks are there. So after detecting the R peaks, we just perform the beat segmentation by choosing certain time duration window. So before the R peak, 10.25 second offset we have chosen, and after the R peak, 0.45 second offset we have choose. And according to the time duration and with the sampling frequency, we can just multiply and we can just select the samples. So before the R peak, 89 samples have been taken, and after the samples, R peak, 162 samples have been taken. So based on that time offset, the number of number of samples have been chosen here. Now here you can just see T1 is before the R peak, T2 is after the R peak. So we can easily perform the beat segmentation. So in this way, we just use the beat segmentation here. Okay. Now here this is the detail of the TQWT, and since the DWT has itself the very large mathematical background, I will not very much focus, and we have also less time. So simply you just understand that tunable Q-wave transform provide the three tunable parameters by which you can just set the parameter according to the signal for non-stationary signal and get the features. And in this case, the three parameters are, यहाँ पे इसका भी डिटेल हमने लिया है एनालिसिस फिल्टर बैंक का TQWT में, how we can just perform the TQWT, but we will not go very much in depth due to the less time. And regarding the parameters, the three parameters Q, R, and J are the three parameters in the tunable Q factor. So Q factor is one parameter, oversampling rate is another, and number of decomposition level is the third parameter in the TQWT. And apart from that, the scaling factor alpha and beta are also associated with the QRJ, and it is defined in terms of the QRJ. So in the DWT, as I already told you, the downsampling factor is 2. But in this case, it is just defined by the alpha. So आगे के स्लाइड में है. So you can just see if H naught J is denoted by the low pass subband and H1G is just denoted by the high pass subband, then the scaling factor is alpha to the power j, and in the B part, which is the high pass subband, scaling factor is alpha to the power j minus 1 and beta. So overall, this is the same. So it has the advantage here. It is the scaling factor here in the means the difference point you can just say in the DWT and TQWT. Here, a scaling factor is not true. It is just defined in terms of the alpha and beta by this block diagram, whatever I just showed this in this slide. Okay, so in this way, you can perform the high pass filtering using the filter bands, high pass filter band and low pass filter band. You can perform the analysis filter band for the signal XL, which is ECG bit here in this case. Now, regarding the mathematical formulation of this scaling factor, beta can be defined in terms of the Q, 2 by Q plus 1. Alpha can be defined in terms of the beta and R, 1 minus beta upon R. And maximum number of decomposition can be calculated by the lower bound, log beta n by 8 divided by log 1 upon alpha. So in this way, this alpha, beta and j is defined using in T-level Q-level transform. Now here in the implementation, we just use the Q R value, Q value 3.8 and R value oversampling rate 1.8 for the selection of features. And at 6th level of decomposition, last 12 coefficients of the low pass band, which is in DWT approximate coefficients. So that approximate coefficient in the TQWT last 12 coefficients are taken as a feature of ECG bit. ठीक है, तो इसमें फीचर सिलेक्शन के लिए हमने पीसीए यूज नहीं किया, लेकिन पीसीए भी यूज कर सकते हैं. सपोज दैट इफ यू जस्ट गेट द मैट्रिक्स ऑफ द फीचर्स, वी कैन जस्ट अप्लाई द पीसीए फॉर सिलेक्शन ऑफ द पीसीए component, principal components. But here we just by you can just say this is the empirical investigation. Based on the empirical investigation, we just seen that 12 to 15 coefficients are very much significant to classify different types of bits. So here, without making the use of PCA, so it can be also called as the advantage, because PCA takes time. So it will increase the computational time. So in this case, in this paper, I have just focused as the advantage. Without employing the PCA, without employing the selection point, feature selection point, we just use the coefficient and the features, and we just perform the classification, which offer good classification performance in terms of the accuracy, sensitivity, and specificity. So it has the advantage. Next is training and testing data sets construction. Okay, so here you can just say the different classes, 8 different classes are there, and from these records, that much number of data has been extracted as a bit. And from all this data, the features have been extracted. So in the training data set, total 14,878 bits have been taken, and for the testing, 26,219 bits have been taken. And total number of bits is 41,097 in this case. And regarding the SBM model, as I already discussed, here 1 against all strategy is used to classify 8 different classes. First, we just select one, and remaining select as the another class. Again, for second class, class 1, and remaining 7 will be the another class. So 1 against all strategy has been used in this case to classify 8 different classes. And regarding the kernel, radial basis function is used here. And if you are just studying the machine learning or deep learning, you must know the confusion matrix. I think you all you know. जो भी डेटा साइंस के हैं लोग शायद जानते होंगे. What's confusion matrix? जानते हैं? नहीं जानते हैं. So confusion matrix is just created after the classification. Means if P is, suppose that a person is suffered with the disease, so P is the actual, and if a person is not suffered with the disease, means negative. So the actual positive, actual negative. But after the classification, the model predict that the person is suffered or not. So the prediction will be just classified in four types. True positive. Yes, if it is positive and the predicted value is positive, then it is TP. If the person is positive, but the predicted value is the negative, in that case it will be false. So it will be false negative. In the similar way, if the person is negative, but it is predicted as positive, so it is the false positive. And the fourth type is true negative. Means if the person is negative, not suffered with NGs, and it is the predicted and also negative. Means it's the true negative. So based on this TP, TN, FP, and FN, the performance matrix has been defined. So these performance matrices are measures are accuracy, sensitivity, and specificity. And apart from that, nowadays precision and F1 score is also used in the machine learning, deep learning, Python. So you can also use that precision and F1 score. So based on these three performance measures, the values of the accuracy, sensitivity, and specificity are for normal, L triple B, R triple B, APV, P, PVC, FPNV, and FPNV. So the accuracies are mentioned, sensitivities are mentioned, and specificities are mentioned. And overall, if you just take the average, the overall accuracy is 99.27%, sensitivity is 96.22%, and specificity is 99.58%, which are quite low. And it is just in this technique, it has compared in 1920, many more recent papers at that time. Nowadays, the technique has been advanced in within 2 years, many more advanced techniques come to classify different types of engineers. So, the conclusion, I can just conclude the overall discussion by this point. ECG signal is widely used with the AI to detect different classes of diseases related to heart. वहाँ पे full stop missing है. A novel cardiac arrhythmia technique based on the Q-wave transform and SVM has been included here in the slides, and the database has been taken MIT as arrhythmia database. After that, for the pre-processing part, SA filtering, butterworth filtering has been used, and the overall data set created by the total in the data set for the training and testing, total 41,097 ECG bits are taken, and the RPIC detection has been performed using the Pan-Tompkin algorithm, and features for features extraction, cumulative transform has been used. So this is the concluding part, the overall conclusion. The value of the Q is 3.8, R is 1.2, and J value means number of decomposition value is 6. At 6th decomposition, 12 approximate coefficients are taken as features. Low pass subband, जो कि approximate coefficient होता है, that are taken as the features. And for the training data set, 14,878 ECG bits are taken, and for the testing set, 26,219 ECG bits are taken. And the overall performance is in terms of accuracy, sensitivity, and specificity are mentioned here. 96.22, 98.22, and 99.27% in terms of sensitivity, specificity, and accuracy respectively. Okay, so this is the conclusion. Now demonstration and implementation, I have included some codes to show you. So I just so this is the references regarding the paper which I told, the fourth paper. It is just published in Biomedical Signal Processing Control in 2022. And rest are all other reputed international journal paper in this area, which is published by me. Okay, so I just escaped it to show you some code so that you just feel the practical approach of all these codes. So I just run it. तो पहले यहाँ पे मैं मैटलैब ओपन करता हूँ. So meanwhile, if you have any question, then you can ask me.
So for machine learning, in like mathematical portion, how much we're supposed to know? Just the formula or the background is also
So means the thing is basically nowadays many toolbox has come. So you can use it directly from the toolbox. But if you are using something and you should must know about the thing, what is the thing? Because if you just use the mobile phone, you are just using only applications. But what is the background? What is the behind that? You also know. You should also know that as a student. Okay. So study the mathematical background. After that, according to your application, you choose the machine learning tool or deep learning tool. According to user structure.
So, sir, it varies with the case specific, like which approach we are using, or there are some general formulas which are applicable.
First thing is which type of data you are using. Okay. So if we just say regarding the support vector machine, if you just in the kernel of the support vector machine, if you just apply the sigmoid, then it will be not suitable for this situation. So for the data set, which data you are using, according to that, first you choose the tool, which tool you will just use. Okay, and after that, in that tool, what the different regularization parameter, hyperparameters, all are the different parameters. You can just choose the different parameters, and accordingly you just select that. So first thing is the selection of the machine learning or deep learning tool, which tool you have to use. After that, you just study that. After you just know that which kinds of parameter you can change, and after that, you just apply to that data. If you are just getting good results, then you just explore more in that case, and you just perform the. You can just make the coding, and you can just also use for the research publications. Okay.
And so, like if someone is working in healthcare, so we work on a dummy data set which is available on Kaggle and all, or we work on the actual data set.
I just suggest you if you are just using you are working in the healthcare, then don't use them data because whenever you will just give presentation, they will just whatever the expert will come, they will criticize it because dummy data is the generated data, and instead of that, if there is the online available data, that will be quite fine. Okay, either use online available data or you can also collect the data from hospital. Okay. So because many MUs have been done, if you are working in that area. Okay. So here, one I will not take much time. Within 5 minutes, I just demonstrate you the implementation. So here I'm just show you. I just show you. डेस्कटॉप पे हमने रखा है कुछ कोड पढ़ा प्रेजेंटेशन जैसे हाँ बस 5 मिनट 5 मिनट हाँ 5-10 मिनट और लेना बस थोड़ा डेमोन्स्ट्रेट कर देते हैं हाई फ्रीक्वेंसी नॉइज रिमूव करना है ठीक है तो कोड ओपन हो रहा है देखिए हाई फ्रीक्वेंसी नॉइज रिमूवल का ये कोड है अब इसमें हमने सेलेक्ट करेंगे हम सेलेक्ट करेंगे कोई डेटा जो कि ऑलरेडी हमने रखा है यदि आप लोग करते तो मैं डाउनलोड करवाता अभी ठीक है कि डेटा कैसे लेंगे नाउ वी विल जस्ट रन द कोड बाय द एडिटर so here we will just select the folder from which folder we have to just access the data तो फोल्डर में आ गया अब देखते हैं यहाँ पे 100 M का जो डेटा है जो ECG डेटा है डिस्क्रिट टाइम में जो एम्बुलेटरी मॉनिटरिंग से रिकॉर्डेड डेटा है ये अपलोड हुआ और ये रन हुआ अब देखिए इसका परफॉर्मेंस जो कैसे ये नॉइज रिमूव कर रहा है मैं लांच कर देता हूँ so here the first one is which is the red that is the noisy data and you can see in the green signal the noise has been removed है ना तो इस तरह से ये noise को हाई फ्रीक्वेंसी noise को रिमूव करता है again I'm showing you the another code now I can vary the data not only for 100 there are the 48 records I just select 105 again it just removes the high frequency noise देखिए हो रहा है लग रहा है विजुअल इंस्ट्रक्शन से दिख रहा है दूसरा कोड हम रन करते हैं बेस्ट एंड वार्निंग रिमूवल का कोड हमने काफ़ी एक्सप्लोरेटरी वे में इस प्रेजेंटेशन के लिए ही लिखा था। इसमें हम डेटा लेते हैं जिसमें ज़्यादा वेस्टर्न वांडरिंग है 121 में है, तो उसको हम ले रहे हैं यहाँ पे। देखिए वेस्टर्न का वेरिएशंस फर्स्ट में रेड में देखो कितना इस साइड में, वो सारा इक्वेट हो गया, एक लाइन आ गया। तो ये इस कोड का परफॉर्मेंस है वेस्टर्न वांडरिंग रिमूवल
सर
का।
हम लोग सिर्फ इसको इसी डेटा में यूज कर सकते हैं या कोई और एप्लीकेशन?
ये वेस्टर्न वांडरिंग का और में भी यूज कर सकते हैं।
कैसे में सर?
1D सिग्नल जैसे EEG के लिए, EMG के लिए, इमेज में नहीं यूज होगा क्योंकि इमेज में वेस्टर्न वांडरिंग रहता ही नहीं है, ठीक है। वो 1D सिग्नल पे ही यूज होगा। इमेज में डिफरेंट आर्टिफैक्ट्स होता है जैसे ब्लैक होल आर्टिफैक्ट, उसके लिए भी फिल्टरिंग टेक्निक या मास्किंग टेक्निक आता है, यू कैन यूज इन दैट, ओके। अब एक है कि वेवलेट डिकम्पोजिशन, एक मैं बताता हूँ, उसके बाद मैं स्टॉप करता हूँ इसको लेक्चर सेशन को। वेवलेट डिकम्पोजिशन क्योंकि इसको हम जैसे DB6 फैमिली से इसको डिकम्पोज कर रहे हैं अप टू 5 लेवल। सो वी जस्ट सेलेक्ट द data first. So here we just select the data, after that perform the decomposition. So up to 5 level तक ये decompose हो गया। तो L part जो यहाँ पे है that just show you the level information, and C part is the just give you the approximate and return coefficient. So if you will just click on the C1 part, so here this is the overall coefficients, approximate coefficient, return coefficient, and you can also plot it. देखिए ये coefficients का plot है। Now the advantage is here in this plot you can just see the energy is compressed. Not frequency coefficients और maximum amplitude है। So we can just say discrete Fourier transform compress the energy of the signal to few coefficients. So it can be also used for the compression. और इसके जो coefficients का जो है जैसे low frequency coefficients, approximate coefficients जो है that can be also used as the features क्योंकि high amplitude है इसका। इसको features जैसा मैं QQWT में लिया वो ये नहीं है, हालांकि इससे advanced है, लेकिन इसी तरह का चीज है उसमें। And in this way you can just extract the features and you can just perform the classification. Okay. So I just stop this lecture at this point and thank you very much.
दिखा रहे थे सर, उसका सोर्स क्या मींस कहां से आप क्लिक करेंगे?
MIT BI एरिया डेटाबेस, वो ऑनलाइन अवेलेबल डेटाबेस है, उससे लिया गया है। Okay. So if you have any more question query then you are most welcome. एग्रीकल्चर वगैरह में आप लोग इमेज बेस पे कर सकते हैं, ठीक है। उसमें देखिए एक्सप्लोर कीजिए।
सर थोड़ा सा आप बेसिक बता देंगे तो कहां से एक्सप्लोर करें, कैसे शुरू?
फर्स्टली है कि आप लोग देखिए सबसे पहले मेरे ख्याल से आप लोग कीजिए क्या, एक तो ऑनलाइन अवेलेबल डेटा बहुत सारा होगा। मैं देख रहा था कुछ दिन पहले मैं सर्च कर रहा था क्रॉप्स प्लांट से डिसीज का, तो उसमें ऑनलाइन अवेलेबल डेटा है। उस पे आप लोग मशीन लर्निंग को रन कर सकते हैं, ऐसा वेक्टर मशीन लगा सकते हैं, डिसीजन ट्री लगा सकते हैं, रैंडम फॉरेस्ट है वो लगा सकते हैं, या आर्टिफिशियल न्यूरल नेटवर्क लगा सकते हैं, वो चीज कर सकते हैं। दूसरा है डीप लर्निंग, पाइथन बेस्ड डीप लर्निंग यूज कीजिए, तो डीप लर्निंग का भी मॉडल बन जाएगा। यू जस्ट पुट द इमेज and perform the classification, and if you just want to help any help then I can help you.
सर लंच के बाद तो हम लोग करेंगे ना हैंड्स ऑन,
कुछ टीचिंग प्रैक्टिस है ना, कुछ टीचिंग प्रैक्टिस है। You can also ask, आप अभी कोई क्वेश्चन है तो then you are most welcome।
कुछ हम लोग करेंगे तो फिर क्या है क्वेश्चन पूछना? हैंड्स ऑन रहता तो फायदा था सर, प्रैक्टिकल
हैंड्स ऑन तो मैं कोड रन कर रहा हूँ,
हम लोग रन कराते तो थोड़ा सा ये होता है, इसका बेनिफिट होता है।
आएगा भी हमें कभी दिया जाएगा।
due to some urgent involvement of some staff members उस वजह से नहीं हो पाया, नहीं तो उसका पूरा प्रॉब्लम था। ये कोड हैंड्स ऑन के लिए ही था।
अभी तो सर ये चीज हैंड्स ऑन का ही है सर, कल थ्योरी पढ़ के क्या ही करेंगे?
थ्योरी नहीं, प्रैक्टिकल भी है इसमें। ये प्रैक्टिकल के यू कैन कम हियर एंड यू परफॉर्म। ओके, यहाँ मैटलैब है, आइए परफॉर्म कीजिए।
ठीक है सर, मींस हम लोग को अगर कुछ इस तरीके से हो जाता तो सीख लेंगे।
नहीं, अच्छा है, नॉलेज पॉइंट ऑफ व्यू से सीखना चाहिए। But for the time instance, you can just take all this knowledge, and if you have any query, doubt, then you can ask me. Okay, you can consult. वो भी करना होगा नहीं
सेशन होगा
हैंडसम होगा पूरा हैंडसम ही है ये भी हैंडसम ही था लेकिन कुछ इन्वॉल्वमेंट है स्टाफ्स का जिस वजह से यहाँ पे मैटलैब शायद ये आता है वो हो जाएगा आपको नेक्स्ट वर्क हैंडसम सेशन नहीं मिलेगा ओके
ठीक
रिकॉर्डिंग